Hello, let's do the New York Times Hard Sudoku for December 4th, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, for now we are continuing with the holistic pass up front, which speeds up the solve, potentially. So I'm just going to look for, say, this box here has 4 givens in it, and they're kind of clustered, so that's a good place to start looking. Am I seeing anything though? 2, 6, 2, 1, 1, 2, 6. Nothing that's like worth that like pops out to me at the moment. Actually, no. Yes, sorry. There's definitely something here. We have the 168 here. So this is our classic New York Times trick. This is what we're like most looking for, which makes me sad that I didn't see it immediately. It was a little bit obscured by this 2 here and me thinking about this column more than this row, but we do have it here. So what are we looking for? Well, we're looking for a box with 3 givens in it. These are the 3, at least 3, right? In this case, there's 4, but these are the 3 I care about. I'm going to mark those in green, and then they all avoid a row or a column. In this case, they're all avoiding this column and this row, but they all avoid a row or column that also has 3 givens in it outside of that box that do not match our green digits. So I'm going to call those the purple digits. Notice that 3, 4, and 7 do not match 1, 6, and 8. So we got these 3 givens, which we'll call green, and we got these 3 givens, which we'll call purple. So the question that we can then ask is, where in row 4 do the green digits go? Because every row, column, and box will have 3 cells with green digits in it, 3 cells with purple digits, and we'll just call the last 3 the blue digits, but we haven't marked what those are yet. So we've kind of divided our 1 through 9 into green, purple, and blue. Green being 168, purple being 3, 4, 7, and blue being the other 3. So every single row, every single column, and every single box will have 3 greens, 3 purples, and 3 blues. And so the question is, where do the 3 greens go in this row? And you should be able to visually see, well, they can't repeat in the box because the box already has 3 greens, and they can't be on top of the purple cells. And so these are where the green cells go. I'm not even going to mark digits in them yet. I'm just going to color that. And that means that these 3 are going to be our blue digits. And you can also see that these had to be the blue digits because they saw all 3 greens and all 3 purples. So they couldn't be a green or a purple digit. And then now you can actually see in this box that the green digits, or sorry, not the green, the purple digits actually end up in these 3. So you end up with this coloring. So when we find these 3 givens that all avoid a row, and in that row you've got 3 more givens outside the box that are different, I don't know a more concise way to put that, then you always end up with this situation. And you don't have to color it, but coloring helps me demonstrate what's going on. So now what we can do is we can think about, okay, well, you can do this in any order you want, but I like to fill this first. So we know that these are the green digits. So these have to be 1, 6, 8. And I'm seeing this cell can't be 1 or 6. So if you want, I could mark these as green, right? I could go through the whole puzzle. And I could say all the 1s are green, all the 6, I have to keep switching modes. All the 6s are green and all the 8s are green. And then we've got all the 3s are purple. All the 7s are purple and all the 4s are purple. And then all the 2s are blue. And then the 9s are also blue. And then the 5s are blue. So if you want, you could color the entire puzzle this way. I don't recommend it. It's just going to take time. But you can see here that now we can see that there are already 3 greens in this column because this is green and the 1 and 6 are gone. So this has to be the 8. And then we're left with a 1, 6 pair here. And then we know that the blue digits are the 5 and the 9. This 9 looks up. So this can't be the 9 or the 2. So this is 5. Sorry, it's 2, 5, 9, right? But the remaining 2 were 5 and 9. So that's the 5, that's the 9. Now we know these are 3, 4, 7. And this purple looking in tells us that's not the 4. So the 4 is in one of these 2. Otherwise, they are 3, 4, 7. And then, you could continue with, with these colors, but I don't think it's particularly useful. I'm actually seeing that we have these 9s looking into this box now. And so the 9 ends up here, which is blue. Might as well keep the colors while it's helpful. And we have also this new 9 I placed along with this 9. This 9 also looks up, places the 9 in this box. We do have quite a few 9s. These 2 9s look in, this 9 looks up, placing a 9 in this box. And then these 9s look in, this 9 looks in, placing a 9 in this box. And 9s are actually done, which is quite nice. All right. So I'm just, while I have the colors here, I'm just considering blue, the third blue in this column, which would be the 5, but it can really go anywhere. All right, so I am going to get rid of the colors now, and we're going to do continue with normal scanning, but you can see we got quite a bit out of that. We should examine to see if we can follow up on any of the digits we just placed. Most of them are 9s, which we already finished all the 9s. So it's really just the 5 and the 8, which we do have 2 8s looking in here. That didn't really help. This 8 didn't actually help that, but let's just mark an 8 on these two. I'm looking at 8s. All right, so we're going to look for more that we can do here. I want to think about this box because I just placed a bunch in it, and it's only got 4 digits left. We need a 1, 5, 6, 7. So we know this isn't 1, so it's 5, 6, 7 for what it's worth. These aren't 6. The 6 is one of these two, and these are 1, 5, 7. All right. I'm looking for crossings on this 4, 7 because we've got quite a few givens in the column. So 2, 3, and 8 could all cross it. And I'm actually seeing both the 2 and the 8 are doing it. So 2 and 8 with this 2 and 8 look in. These aren't 2, 8. And so there's only 2 cells left in this box that can be 2, 8. So those 2 cells are 2, 8. One of them's 2, the other's 8 in order to fit both in. And so that leaves just 4 digits behind here, which are the 1, 3, 5, and 6. 1, 3, 5, 6. These can't be the 1. So the 1 ends up in one of these two. That is going to point. So that can't be 1. That can't be 1. Trying to see if there's an immediate consequence. There doesn't seem to be. So these are 3. Sorry, what did I say? 5, 6, 8. Sorry. Did I say the correct digits? Let me just look at it again. We need the 1, 3, 6, 8. I think that's what I said. So these are 3, 6, 8. That's not a... oh, this can't be 3. Oh, the 8. Sorry, not 8. Let's do this again. 1, 3, 5, 6. 1, 3, 5, 6. So these are down to 3, 5, 6. And this isn't a 3. What's wrong with me? The 3 actually looks up. Oh, these 3s look in. And this hidden 2, 8 removed 3 from here. So this is where the 3 goes. We should follow up more with 3s. Anyway, this is a 7. Ah, yeah, we have a 3, 4 pair here now. This is not a 7. And so we have a 3, 4 pair and a 2, 8 pair. 1, 5, 7 is what's left. So this is 1, 5. It's not a 7. So 7's over here. All right. That was quite nice. We've reduced this column to 4 digits. We need the 1, 5, 6, 7. 1, 5, 6, 7. Wow, there's nothing to see there. Oh, this can't be 6. This is 1, 5, 7. In fact, we do have 2 6s looking in, so let's mark that. All right, anything else in our holistic pass we want to look at? I'm noticing these 3, right? This is our potential, like we just did earlier, our potential little trick here. But unfortunately, the 6 and the 9 both repeat. So we can't actually do that trick. But we can think about 8 in this row real quick, but it doesn't do much. We can also think about the 2 looking in, and whether that's helpful. And it actually is. It crosses the 8, 9. So we have a 2 in one of these two. That points in. This 2 looks in. This 2 looks down. That places the 2 in this box. These 2s look up, putting a 2 in one of these two. All right. Anything else to look at? This 2, 3, 9. So we already have 3 and 9 placed. We need a 2 in the column, but there's plenty of spots. We can think about the 4 looking down. Yeah, we have 2 4s looking down, so 4 is one of those two. All right, I also want to look at this column, which is down to 4 digits. We need a 3, 4, 5, 7. So this isn't 3, it's 4, 5, 7. Otherwise, nothing. This row is down to 4, 5, 6, 7. This is 4, 5, 7. This is 4, 5, 6. And this is 5, 6, 7. All right, I think it might be time to go to systematic, because I'm not seeing anything else. And if systematic, we'll find it. All right, if there is more. So we're going to go back up to box 1 here. We're going to look at 1, 4. So 9, we know 9s are done, so we're just going to look at 1, 4. So these 2 4s look in. This 4 looks up. Yeah, so that's one I missed, for example. Now these 4s look down, putting a 4 in one of these 3. 3 looking in, and this 3 looking in puts a 3 in one of these 2. Did getting this 4 do anything else? Oh, this column is down to 3 digits. How did I miss that? We need a 2, 3, 7. So I'm just seeing that this one's not a 3. Oh, and this one's not a 2? In the box, right, okay. So yeah, we knew 2 was up here. 2, 3, 7. Okay. Anything else in this box? The 5. All right. I'm not seeing anything else in this box. 4, 5, 9. We need to. Yeah, nothing. All right. We got 3, 4, 8, 9 in here. So we obviously we have a 9 everywhere. We got the 4s, the 3s, the 8s. I'm not seeing anything else to do in this top band. Feels like there should be something, but I'm not seeing it if there is. This band we took care of. Let's just look at this final band here. So we have 6 and 8. We also have this 6 and 8. So let's do the buddies. So 6 is up here. We already have the 8s marked. We also did 6 here. We have 1. We have 2. Okay. One, 2, 6. I'm not seeing anything else from our. Yeah, so I basically found everything almost everything that Systematic would have found during my holistic. So we're still not done. So what we're going to do is we're going to go row by row now. So that was just Systematic based on our initial boxes, mostly looking for buddies and geometry. But this next pass, we're just going to go row by row, and we're going to just look at what the row's doing. Looking for pairs, looking for triples, looking for cells maybe worth penciling. So for example, this row we know is down to 4 digits. So let's just take a look at what those 4 are. We need a 2, 3, 6, 7. 2, 3, 6, 7. Well, this isn't 2 or 3. So this is down to 6, 7. This is not a 2. So this is 3, 6, 7. Oh, wow. That's a 2, 3, 6, 7 quadruple in this box. Basically, the other way to think about it is where do the 1 and the 8 go? So we have this 1, 8 looking in. We have this 1, 8 looking in. So I missed 2 crossings on this 4, 9, probably because I got the 4 late. So I stopped looking for crossings, but I should have looked for crossings on that 4, 9. I would have seen the 1, 8 here and the 1, 8 here. So this is a hidden 1, 8 in the box. Much easier to spot than penciling a quadruple and then noticing that it's a quadruple. But the 1, 8 pair removes 8 from here, so that places our 8. What else can we do? This rest of this row can't be 1, 8. So we are down to 2, 5, 6, 7. 2, 5, 6, 7. This can't be 5 or 6. So this is 2, 7. This is 2, 5, 6, because it's not 7. This can be any of them. I'm noticing this is a 2, 7 pair, though. So this can't be 2, and this is down to 5, 6. We have a 1, 8 pair, a 2, 7 pair, and a 5, 6 pair. I also noticed this column is now down to 3 digits. We need the 2, 3, 7. Bottom one's not a 2. So the 3 is here, one of these two. That is going to claim. So what I mean by claiming, well, this box needs a 3. It's going to be here or here. Wherever that 3 ends up, it's also in this box. So the rest of the box can't be a 3. So we say that column 3 claims the 3 from box 7. So if these aren't 3, that does affect this column. This is down to 4, 5, 7. Oopsie. And this is down to 3, 5, 7. Okay. Oh, this is another quad. No, it's not. If the 2 weren't here, it would be a quad. What are the other digits? What's the other digit? 1. The 1. So yeah, the 1s look in. Why can't this be a 1? Oh, the 2 1s look down. I missed the buddy 1s. Okay, anyway, 1's one of those 2. Not doing great today, but we're getting there. And that's where Systematic really saves us, is when we're not thinking well. It still gets us through the puzzle in a nice, clean way. I'm not seeing anything else with rows. I'm going to look at columns. 4, 3, 4, 5, 7. This can't be 1 or 6. I think this is worth marking. It's not 1, 2, 3, 4. Could be 5. It's not 6. Could be 7 or 8. So 5, 7, 8. Interesting. Interesting in that it's not interesting. Sorry. Just a completely eclectic mix of digits. All right. 5, 6, 7. Let's look at this whole box. I'm curious because I don't have anything going on in it. We need a 1, 2, 5, 6, 7. So this can be 2, 5, 6. Oh, it's not even a 5. It's not 1 or 5 or 7. So it's down to 2, 6. Does that... See, I've got a 2, 6, a 2, 8, and a 5, 6. And a 4, 5, 6. It's kind of weird. Maybe this whole row, 2, 3, 6, 7. This is 2, 3, 6. Okay, so we have 7s claiming in this row. This can't be 7. This can't be 7. So the 7 goes in one of these two. And remember, claiming means that the rest of the box can't be 7, because this row needs to place the 7 here or here. Wherever it places it, these aren't 7. So you can see that makes this 2 and 3 and 7. It resolves the column. This 2 gives us the 7 here, giving us the 5 and the 6. So we're left with 2, 3. This 3 looks in, so that's 2 and 3. All right, so we're left with a 6, 7 pair here. This is the 2 for the row. This is the 5 for the row. We get the 8 and the 2. We get the 4 and the 3. These aren't 5s. Over here we get 3 and 2. All right, so this wasn't the quad I thought, because the 2 did end up there. None of these are 7. This isn't a 5. All right, what are we doing with all that? This is a pair. We need a 1, 5 pair. What else did we do recently? Let's see. Maybe just this triple will be helpful. We need a 1, 6, 7. That's not a 7. So this is 1, 5, 1, 4, 5, 6. This isn't 6, so this is 1, 4, 5. That's a 1. Oh, actually, we have a 1, 5 pair in the row, so this can't be 1 or 5. This is a 4. I was going to say it was a triple, but this is our 4. Wow, just a quad. So 1, 5 pair leaves behind 2 more digits. We need the 3. This can't be the 3, so 3 goes there. And we need the 8. 5, 6, 7, not a 6. So 5, oh, it's not a 5 either. So this is 7, 6, and 1. We get our 5 and 1. We get 5, 6. Oopsie, I messed that up. Sorry, I messed something up. Let's go back a little bit. Was this right? The 3 and the 8? I think so. So what did I mess up here? 1, 5, 6. Oh, I have a lot going on here. Okay, let's try this 6, 7. I hope I just kind of typoed something. This is 5. This is 1. This is 5. We get the 6 and 7. This is 1 and 6. What's this digit? The 1. Okay, it's working now. I don't know what I typoed before, but I just sort of approached it from a different direction after undoing a little bit. All right, so we get the 1, we get the 6, we get the 8 and the 1, the 7 and the 6, the 5 and the 7. That's 8. We get 5 and 1, 4 and 7, 5 and 4, and we're done. Oh, phew, I didn't make a mistake earlier. I'd have to look at the footage to see, like, what did I typo or misread in here, but approaching it just from this column ended up being correct, so who knows. All right, well, I hope that was interesting. I know this was a longer solve, but because it definitely involved more explanation. I hope that was helpful. That's definitely the kind of thing we're on the lookout for when doing that initial holistic pass, because it gives you a really nice seed into the puzzle of like, ooh, we get a nice flurry of deductions and restrictions before we even start on our systematic scan. And that's the whole point of the holistic pass. All right. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.